In this example, we are going to be talking about a shell. We're going to use a shell method, but it's going to be bounded by two curves. So remember, if we're doing a shell method, it's usually because we are rotating around a y-axis, and we don't want to change things into terms of y's. It doesn't really allow us to, and so we have to leave it. So, but the problem is, or what's different on this situation is, we're going to have finding a volume between two curves that's going to be rotated around a y-axis. So the little bit of a difference is we still have this 2 pi r-ish kind of thing, which is the width of these cylinders as we unroll them. So just a quick visual again, that we're doing these cylinders, and then these cylinders kind of unroll into these prisms, and that width right there is our circumference, which is a 2 pi r. That r is our distance out, which is actually an x value. And then our height is based on whatever equation we got going on. So, so this is our circumference piece. Our height is going to be, because it's between two curves, we're going to be taking the high equation, the equation on the top minus the equation on the bottom. So the higher equation minus the lower equation. All right. Otherwise, everything else is exactly the same. So trick is we need to figure out our graphs here. What do these graphs look like? What do we got going on? The very first thing is I don't know which one's going to be on the top. I assume this one is going to be, because this is, well, no, sorry, this one's going to be on top because it's a parabola that's looking like this, and this is a parabola that's going up. So this one, they're going to overlap each other, and I'm sure this one is going to be the higher equation. We'll be subtracting the lower equation. But I also need my bounds on this. So let's just take this equation and set it equal to this equation and start by seeing where do they intersect. So if I take negative x squared plus 4x plus 2, set it equal to this quadratic, x squared minus 6x plus 10, and start to solve. So if I start to solve, I'll bring this over, bring that over, bring that over. So we're going to add x squared. We'll subtract 4x, and we'll subtract 2 by bringing those over. So we'll have a 2x squared minus 10x plus 8 equaling 0. If we take a 2 out, we'll get an x squared minus a 5x plus 4 equaling 0. And then this factors into an x minus 4, x minus 1. So we get these graphs are crossing each other at x equals 4 and x equals 1. So in general, I don't know exactly what these graphs look like, but all I really need is at 1 and at 4, they intersect each other. And they may not be symmetrical or anything like that. I don't really care. I just know that this quadratic is going to have a downward face to it. So it's going to look something like that. And this one's going to be going up. So it's going to look something like that. And so this is my high graph. It's my low graph. All right. So when we start to set all this up, we are finding our volume. Our equation is we are doing the integral of 2 pi x times the high function minus the low function dx. That's what we got going on. All right, so for ours, our volume is going to be us going from 1 to 4. That's our bounds. And 2 pi x. This is the higher function. So we'll take that negative x squared plus 4x plus 2 minus the other quadratic, which would be the lower quadratic, at least during that period of time, plus 10 dx. All right, so we got a couple steps that we need to do in order to do our antiderivative. First is I got to put all this together. I'm going to take the 2x out, or not the 2x, the 2 pi out. I'm going to go 1 to 4, and then I'm going to have an x to distribute into this. So if I have a negative x squared minus x squared, I get a negative 2x squared. If I have a 4x minus a negative 6x, I'm adding, so plus 10x. And then a 2 minus 10 is a negative 8. And then let's distribute that in. So 2 pi from 1 to 4 of a negative 2x cubed plus 10x squared minus 8x dx. All right, we're ready to do our antiderivative. So if we do the antiderivative, we're going to have 2 pi, and we're going to have a fourth power, so a negative 2x to the fourth divided by 4 plus 10x to the third divided by 3 minus 8x squared divided by 2. And we're going to go from 1 to 4. All right, so if we plug in, we're going to take a 4 to the fourth power, and then this thing simplifies as well. So let's simplify it first before we plug some stuff in. So this is looking at a negative 1/2 x to the fourth plus a 10/3 x to the third minus 4x squared from 1 to 4. All right, so let's plug in some values. So 4 to the fourth, and then we're going to take half of that and multiply it by a negative. So if we throw that into the calculator, that's going to give us a negative 128. And then 4 to the third times 10 is 640 over 3 minus, this is basically 4 cubed, which is 64. So that's all that stuff, minus plugging in the 1, which is just going to be the fractions and the whole number. So that's going to be a negative 1/2 plus 10 over 3 minus 4. All right, almost. So we have, let's see, we'll have a negative 128 plus a 640 over 3 minus a 64. We'll distribute that in. Plus a half minus a 10/3 plus 4. And if we put that together, and we put our whole numbers together, that's going to get us a, let's see, negative 128 and negative 64. Negative 128 plus negative 64. Sorry, can't see that. Plus 4 gets us a negative 188. Then 640 minus 10, 640 over 3 minus 10 over 3 is going to be a plus 630 over 3 plus a half. So if we divide that out, that's going to be a 210. So we'll have 2 pi times a negative 188 plus, just to make sure, 630 divided by 3, 210 plus a half. So 210 minus 188 gives us 22. So 2 pi 22 plus a half divided by a 2. So 22 is 44 over 2 plus 1 is 45 over 2. And that 2 will cancel that 2, leaving us with a 45 pi for our volume. All right, so that was a lot. And it was really the algebra that was way more than the calc. But if you want to leave things in terms of x, and you're going to rotate something around the y-axis, then you're going to need to do the shell method. And this one happened to be an area between two curves that's being rotated around. And so we needed to take the high function minus the lower function, and then just plug it in, excuse me, to our formula.